Hey everyone! Today, we're talking about a fascinating question. What exactly is a vacuum and how does space work? More specifically, why don't fans work in space? To start, a vacuum is a space with extremely few particles. Scientists have created very good vacuums here on Earth. The best one was inside the Large Hadron Collider. It's almost completely empty of matter. Even in that vacuum, there are still a few particles left. Surfaces trap tiny gas molecules. To improve the vacuum, scientists heat the walls. This releases trapped particles so they can be pumped out. After heating and pumping, the vacuum gets even better. Cooling the surfaces further reduces remaining particles, but no vacuum is ever perfect. There is always something left inside. Now consider outer space. The vacuum of space is far emptier than anything we can make on Earth. Between planets, particles are extremely sparse. Fans have almost nothing to push against there. Between stars, it gets even emptier. Particles are spread out across vast distances. Between galaxies, it's nearly unimaginable. On average, there's only one particle per cubic meter. Even with so few particles, space is not completely empty. Light still travels through it. Virtual particles pop in and out of existence. The fabric of space-time itself still exists. So even a perfect vacuum would still have some activity. To remove absolutely everything, you'd have to eliminate space-time too. That's beyond anything humans can create or measure. Fans rely on moving air or particles. Without enough particles, spinning blades do nothing. That's why fans don't work in space. They can rotate, but they cannot move the vacuum. The laws of physics still apply in space. Gravity, electromagnetism, and other forces continue to operate. Even empty space follows these rules. The universe keeps functioning normally. Scientists study vacuums to understand matter and energy. Superconducting materials require very clean environments. Space provides the ultimate natural laboratory. Researchers often compare artificial vacuums to space conditions. Heating walls in a vacuum chamber releases stuck gas molecules. Pumping removes them again. This cycle improves the vacuum dramatically, but it still cannot match interstellar space. The cosmic microwave background travels through space. Light continues to pass even in extreme vacuums. Virtual particles constantly appear and disappear. Space is never truly nothing. If you remove all particles, you still have space itself. Removing space would be like removing the rules of physics. That concept is more theoretical than practical. It challenges our understanding of nothing. Vacuum experiments show how matter interacts with energy. They reveal the limits of particle removal. Even the best vacuums still have residual gas. Space is orders of magnitude emptier than these labs. Fans in space are essentially useless. Without air or particles, no force is transmitted. The blades spin freely, but nothing moves. That's a clear example of how different space is from Earth. Even between galaxies, where one particle exists per cubic meter, physics operates. Gravity still acts over vast distances. Light still travels uninterrupted. Space is empty but full of rules. Understanding vacuums helps us understand the universe. It shows the difference between earthly experiments and cosmic reality. It explains why things like air pressure matter, and why space behaves so differently. So next time you imagine spinning a fan in zero gravity, remember this. Fans need air to work. Space has almost no particles for them to move. The universe obeys the laws of physics regardless. In conclusion, a vacuum is never truly empty. Space is a near-perfect vacuum with few particles. Yet, physics continues to operate everywhere. Fans won't work, but the universe still functions perfectly.